Now let us solve question number 13. What question number 13 says, if f of x, rather capital, cos x, sin x, 0, second column minus sin x, cos x and 0, and the third column is 0, 0, 1. Then we have to show that f of x into f of y is equal to f of x plus y. That means we need to replace this x by y, then we will get a new matrix f of y, and then we will replace this x by x plus y, then we will get another matrix. Then multiplication of these two must be equal to that they replaced with both the variable. That is, first of all, let us see. This is 1. From 1, put x is equal to x plus y. What will happen? F of x plus y left hand side, and the right hand side is cos x plus y, sin x plus y, 0, minus sin x plus y. Wherever there is x, we will be putting x plus y, cos x plus y, 0, 0, 0, 1. This is second equation. Then this is our right hand side. We have to make it equal to with the product of these two. Now f of y means wherever there is a x, we will replace it y. So this cos y, simply sin y, 0, minus sin y, cos y, 0, 0, 0, 1. This is third. Now this is f of y, this is f of x. What this statement says, find the product. So we will multiply f of x into f of y. This is equal to cos x, sin x, 0, minus sin x, cos x, 0, 0, 0, 1 first, and then second matrix, this cos y, sin y, 0, minus sin y, cos y, 0, 0, 0, 1. Now just remember that thing, orders and then product rule. So what is the order of this? 1, 2, 3, 1, 2, 3. So its order is 3 by 3, 1, 2, 3, 1, 2, 3. So now we multiply it. So what we are going to do here, cos x into this, again same rule, first row and then first column, then the same first row and then second column, and then same first row and then third column. This process will continue until these 3 rows complete. So now we will multiply cos x into cos y, next element, minus plus minus sin x into sin y, 0 into 0 plus 0. Middle term, second column, first row, cos x into minus, so minus cos x sin y, cos x into sin y, minus into plus, again minus sin x into cos y, and then the last one, this 0 into 0 plus 0. Now the third row, cos x into 0, 0, minus sin x into 0 plus 0, and then 0 into 1 plus 0. So there is no issue of cos a plus b. This is minus because of that. So cos x plus y. This is, we are taking minus common, then cos x sin y plus sin x cos y. So this will become minus common sin x plus y. Third one, all three zeros, so 0. Second one, again sin x cos y plus cos x sin y. So sin a plus b, x plus y plus 0, that is over. Then cos a cos b, cos a cos b minus sin a sin b. So cos a plus b, cos x plus y, again 3 zeros, so 0, 0, 0, and then last is 1. So now let us go back to the equation number 2 and check whether our this thing is equal or not. The equation number 2 is cos x plus y. Let us see, cos x plus y, sin x plus y 0, sin x plus y 0, minus sin x plus y, cos x plus y, and then 0 and the 0, 0, 1. That means this is equal to right hand side, hence proved. This is complete. Question number 18. That is, if matrix A is 0 minus tan alpha by 2 plus tan alpha by 2 and 0, and I is the identity matrix of order 2. Order 2 means 2 by 2. We have to show I plus A, that means identity matrix plus this matrix, is equal to I minus A, again that is identity matrix, subtracted this into this, into cos alpha minus sin alpha, cos alpha. This is the question. We are going to start with this I plus A. So I would be equal to 1 0 0 1, identity matrix 1 1 2 2, 2 by 2. Now we will add it into this one. So I plus A means 1 0 0 1 plus 0 minus tan alpha by 2, tan alpha by 2, and then 0. So we are adding 1 plus 0, 1, 0 plus this one minus tan alpha by 2, 0 plus tan alpha by 2, tan alpha by 2, and 1 plus 0, 1. This is our, this left hand side of 1, you can say, equation number 2. Now we are going to find out first I minus A. So identity matrix minus A means 1 0 0 1 minus 0 minus tan alpha by 2, tan alpha by 2, and 0. So what we are going to do, 1 minus 0 1, 0 minus into minus plus, so it is tan alpha by 2 plus में होगा, and then 0 minus tan alpha by 2, so it is minus tan alpha by 2, and 1 minus 0 1. So this is our another factor of this product which we are going to find out lastly. So now I am going to write the final step of right hand side, that is I minus A into cos alpha sin alpha minus sin alpha and then cos alpha. So I minus A is nothing but this one, so we are going to put the value of this one, 1 minus tan alpha by 2, tan alpha by 2, then 1, and multiplied by this particular matrix cos alpha, sin alpha minus sin alpha, and then cos alpha. This product we are going to multiply it as we have this now. We are going to multiply this first row with first column, similarly first row with this column, and then second row with the first column, second row with this thing. So now let us break this tan alpha by 2 into sin upon alpha cos alpha plus sin alpha by 2 upon cos alpha by 2 into sin alpha minus sin alpha plus sin alpha by 2 upon cos alpha by 2 and cos alpha. Similarly here also minus sin alpha by 2 upon cos alpha by 2 into cos alpha plus sin alpha, and then tan alpha sin alpha by 2 upon cos alpha by 2 into sin alpha plus cos alpha at last, taking LCM everywhere. And then we get what we get: cos alpha into cos alpha by 2, cos alpha into cos alpha by 2, sin alpha into sin alpha by 2 upon cos alpha by 2. Cos alpha by 2 will come here, minus sin alpha cos alpha by 2 plus cos alpha sin alpha by 2. The second one is minus sin alpha by 2 cos alpha plus cos alpha by 2 into sin alpha plus sin alpha by 2 into sin alpha plus cos alpha by 2 cos alpha upon cos alpha by 2, cos alpha by 2 and cos alpha by 2 everywhere. Cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Cos A minus B. Cos A, yes, you can take it sin A cos B minus cos A sin B. So sin A minus B upon cos alpha by 2 upon cos alpha by 2. Similarly here also sin A cos B plus cos A sin B. So you can write here sin alpha minus alpha by 2 upon cos alpha by 2. And the last one is here this sin alpha by 2 cos A cos B plus sin A sin B. So cos A minus B upon cos alpha by 2. Now this is again taking LCM 2 alpha minus alpha cos alpha by 2, 2 alpha minus alpha upon cos alpha by 2. Cancel. taking LCM 2 alpha minus 2 alpha minus alpha by 2, and then sine minus theta minus sine theta, so minus will come out, sine alpha by 2 upon cos alpha by 2. Here 2 alpha minus alpha, again alpha by 2, so sine alpha by 2 upon cos alpha by 2, and then cos alpha, 2 alpha minus alpha, alpha by 2, so cos alpha by 2 upon cos alpha by 2, these two also cancelled. As we have here 1 minus sine upon cos tan alpha by 2, sine alpha by 2 upon cos alpha by 2, tan alpha by 2, and this is 1. So we are going to write here what we were supposed to prove that this I minus a into this one is equal to I plus a. Now what is I plus a? I plus a is 1 minus tan alpha by 2, tan alpha by 2, 1. That means this should be our answer. Let us check it there. So 1 tan alpha by 2, 1 tan alpha by 2, minus tan alpha by 2, minus tan alpha by 2, and 1 minus tan alpha by 2, 1. And that means is equal to right hand side, hence proved. So that's how we have completed this question. Number 19. A trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide rupees 30,000 among the two types of bonds. If the trust fund must obtain an annual total interest of part number 1 rupees 1800 and part number 2 rupees 2000. This question is actually application of this matrix, how this interest calculation and this trust bond must be divided into two by this application of matrix. So here we start question number 19. The total amount money was rupees 30,000. Interest for first bond is equal to 5% and interest for second type of bond is equal to 7%. So the part number A is we need to divide this 30,000 into two parts, so that by investing that money into two parts, first part in first type of bond and the second part in second type of bond, so that we get rupees 1800 as interest, and in second part B we get rupees 2000 as interest. So we will start first the part number A, that is rupees 1800. So we must divide this amount into two parts, rupees 30,000, this, and then 5% and then 7%. So let us suppose the first part of money is rupees X, then the second part, that is remaining part, another part will be equal to 30,000 minus X. Now we have divided this part into this amount into two parts, that is rupees X and rupees 30,000 minus X. Now we need to construct a matrix, two matrices, and then multiplication of these two must be equal to rupees 1800. So in a matrix form we will write it like this. This first matrix, X first part of 30,000 and second part is 30,000 minus X, and then second matrix will be this interest 5% and then 7%, and this is equal to rupees, first part, that is 1800. I tell you what did I write. This is actually, what is this formula for simple interest? Principal into rate over 100 is equal to simple interest. So this is what? This is principal amount, and this is what? This is rate 5 and 7, and percent means upon 100. So this is actually indirectly we have used that formula, principal into rate upon 100, this percentage is equal to simple interest, that was given in the question. So we will write it as x 30,000 minus x 5 upon 100 7 upon 100 is equal to 1800. Now check the order of this matrix. 1 1 into first and then second 2, and this is 2 columns. This second matrix 2 rows and 1 column. So this 2 will merge into this 2, as I told you earlier. This is rule of multiplication. Now the order of new matrix would be 1 into 1. So what we are going to do, the row multiplied by the column. So x into 5 upon 100. So 5x upon 100 plus 30,000 minus x, 30,000 minus x into 7 upon 100 is equal to 1800. Now 5x upon 100 plus 7 3s are 21, 1 2 3 4, 2 lakh 10,000 minus 7x upon 100, this 100 is equal to 1800. Now this cross multiplication, 5x plus 2 lakh 10,000 minus 7x is equal to 1800 into 100. Next is 5x minus 7x minus 2x, 5x minus 7x minus 2x, and then plus 2 lakh 10,000 is equal to 1 lakh 80,000. Now this will go that side. You can do here minus 2x is equal to 1 lakh 80,000 minus 2 lakh 10,000. Minus 2x is equal to minus 30,000. Minus minus cancel. Then x is equal to 30,000 upon 2 is equal to rupees 15,000. This is first part of rupees 30,000. Now the next another part was 30,000. We had supposed in the beginning 30,000 minus x. So this is equal to 30,000 minus the value of x is 15,000 is equal to rupees 15,000. So both parts are equal. 15,000 we should invest in first bond, that is which is giving us interest rate of 5%, and we should invest same amount, remaining amount, that is 15,000, into second type of bond which gives interest rate of 7%, so that collectively we get interest of rupees 1800. Similarly, you can try for rupees 2000. Instead of 1800, Now instead of 1800, for next part you will be putting just 2000. That's all about this question. Transpose of a matrix. What is transpose of matrix? Transpose of matrix, suppose we have matrix A, then transpose of matrix is denoted by dash, superscript dash. This is called transpose of matrix. And how we will define? Suppose we have matrix A is equal to 1, 2, 3, 4. Then transpose of A dash will be, what is transpose? When we take transpose of the previous matrix, in new matrix, the old rows becomes columns, old R1, old R2 will become new C1 and new C2. This old R1 becomes C1 and old R2 becomes C2, and then old C1, C2 respectively becomes R1 and R2 of new matrix. So 1 and 2, so that is, we will write 1 here and then 2 will come down here and 3 will go there. That is, second row will become second column, 3 and 4. So this is called transpose of matrix. It's a sub property. The transpose of a transpose becomes the original matrix. That transpose gets cancelled. So means what? Now we have taken A dash is equal to this one. Again we take dash of dash, that is transpose of transpose. Now let us take transpose of this, that will be denoted by transpose of transpose, and then 1, 3, I am writing just simply that same matrix only, and then we are taking transpose of this, which is equal to, this row becomes column 1, 3, this row becomes second column 2 and 4. Now look at here in the beginning, that is 1, 2, 3, 4, 1, 2, 3, 4, same only. So that is equal to A. So this matrix is equal to matrix A. So that means transpose of transpose is itself a matrix. Okay, clear? So now some more properties of transpose. This is first one. This was first. The second, if we multiply, second property, if we multiply to any matrix and takes its full transpose, then constant will come out, and that will be simply the transpose of matrix. I explain how. Suppose we have 4, or suppose we have multiplied any matrix 2 to this, that, whatever it is. Property 1 completed here. Now property number 2, the constant is multiplied to the matrix and then we are taking its transpose, then equal to the constant simply out of the matrix and then transpose of only matrix. What is that? Suppose we have matrix A is equal to 1, 2, 3, 4 and we are K means any constant, so we multiply this matrix by 2, then 2A will become multiplying each element by 2, so that is equal to 2, 2 to the 4, 6 and 8. And then suppose we are taking transpose of this, so transpose of this means 2A transpose whole transpose is equal to transpose of 2 6 4 8. Then it will become 2 4 6 8. 2 4, this first row first column, second row second column. Then we take simply 2 out of this bracket, then this becomes 1 2 3 4. So what is this 1 2 3 4? Is simply transpose of matrix A only. That constant is out of the matrix. That only this property means. Property number 3. Let us we have added two matrices A and B, and we are taking their transpose. Then this transpose will be equal to, if we take separately transpose of A and then added into the transpose of B, the result would be equal. That you can take any simple example and can verify this one. And then fourth one, which is important one property, that product of these two matrices and their transpose will be equal to the transpose of the second matrix into the transpose of first matrix. Their order will change here. Order means the position, the place, first matrix and then second matrix, and then second matrix into first matrix transpose. This is somewhat important than among these three. Another topic is symmetric and skew symmetric matrices. You need to understand the meaning of these two matrices. As you are already knowing, you need to understand now symmetric and skew symmetric. I give you one example. Let us suppose we have one matrix 1 2 3 4. Then we take its transpose of A, that is equal to, column becomes row and row becomes column, 1 2 and then 3 4. Suppose anyhow at any stage this transpose of any matrix becomes matrix, then that matrix is called symmetric matrix. In this case these are not equal, but if it is equal, then if transpose of matrix A is equal to matrix A, then those two matrices are called symmetric matrices. And if transpose of matrix is equal to negative times of that matrix, if it is so, then these two matrices or this kind of matrices are called skew symmetric. Skew symmetric. So you need to understand here, this A dash is equal to minus times A, then skew symmetric. If simple transpose is equal to positive A, then it is symmetric matrix. Now I give you example of each. Let us suppose we have matrix A is equal to 0 2 2 3. Let us take its transpose. Then transpose would be 0, this is row, this will become column, 0 2, and this is row, this will become column, so 2 3. So now look at here, you just compare with this old one, 0 2 2 3, same only. So we can write here A dash is equal to A, means the matrix is symmetric. Take another example. Let us have matrix A 0 3 minus 3 5. Then let us take its transpose of this matrix is equal to, this column will become 0, 3, this row will become column, and this row will become second column, minus 3, 5. Now what is property? If we take minus common, let us take minus common from here, minus outside, then 0, then here plus 3, then minus 3, sorry, here we need to take 0, we need to take 0, the rest of the things are equal. Take another example of skew symmetric. Let us A, we have 0, 3, minus 3, 0, and A dash, that is transpose of this matrix, is equal to 0, minus 3, and 3, 0. This transpose of this row becomes, sorry, yes, row becomes column, and then this row second becomes second column. Now let us take a minus common from each element, 0 and then plus 3 and then minus 3 here, and then this is 0. So you just compare with the matrix A, 0, minus 3, 3, 0. This is nothing but matrix A. So minus A, that means A dash is equal to minus A, means matrix is skew symmetric. So this is about symmetric and skew symmetric. One important rule about symmetric and skew symmetric matrices that you need to understand: any square matrix can be expressed as the sum of a symmetric and skew symmetric matrix. Means what? A square matrix can be expressed as 1 by 2 A plus A dash, which is called symmetric matrix, plus 1 by 2 A minus A dash, which is called skew symmetric. So sum of symmetric and skew symmetric matrices. Now we start exercise 3.3. Question number first, part number first. This exercise is so simple that you can write by your own. The first part is 5, 1 by 2, and then minus 1. The question is find the transpose of this matrix. So that transpose of this matrix is nothing but, this is called column matrix, it will become row matrix, that's all. This column will become one row, 5, 1 by 2 and minus 1. So simple. Similarly, there are so many questions based on this transpose or symmetric or skew symmetric property. So now I take this question number 6, part number 1. If matrix A is equal to cos alpha, sin alpha, minus sin alpha, cos alpha, then verify that transpose of matrix A into A is equal to identity matrix, that is 1 0 0 1 or maybe 1 0 0, depending upon this main matrix, the order of the identity matrix. So now what we have to do first, take the transpose of this matrix and then multiply to it. It should be I. Let us start. A dash, the first row will become first column, cos alpha, sin alpha, minus sin alpha, and then cos alpha. Now transpose of this matrix into the main matrix, so that is equal to this matrix, cos alpha, sin alpha, minus sin alpha, and cos alpha. And then matrix A is this one, cos alpha, minus sin alpha, cos alpha. So order is 2 by 2. Order is 2 by 2. So simple. Square matrices are so simple to multiply. So now the new matrix in new order will be 2 by 2. This and this. So first row and then first column, and then similarly cos alpha into cos alpha, cos square alpha, minus into minus plus, sin square alpha. Second one is cos alpha into sin alpha, minus sin alpha into cos alpha. Second row, sin alpha into cos alpha, minus sin alpha into cos alpha. And the last one, sin alpha into sin alpha, sin square alpha, and then plus into plus plus, cos square alpha. This is identity number 1. Sin square theta plus cos square theta is 1. Cos alpha sin alpha minus cos alpha sin alpha cancel. Sin alpha cos alpha sin alpha cos alpha cancel, and this is again 1 0. This is 0 and this is 1. And 1 1 2 2 position of identity element. So 1 0 0 1 is nothing but identity matrix. Hence proved. Now we take next question. That is question number 7. Part number 1. Show that matrix A 1 minus 1 5 minus 1 2 1 5 1 3 is a symmetric matrix. What did I tell you? What is symmetric matrix? If we take transpose of it, and if its result is equal to itself, then that matrix is called symmetric matrix. Let us take transpose. So transpose of this matrix is, this row will become first column. So 1 minus 1 will be written here, and then 5 at the bottom. The second row will become second column. So minus 1, 2, and then plus 1, and then 5, and then 1, and then 3. Let us check with compare with the old one. 1 minus 1 5 minus 2 2 1 5 1 3. Then that means there is no change. It is itself is a matrix A. So hence showed. That means proved. Matrix A dash is equal to A itself. Second part is show that the matrix A 0 1 minus 1 minus 1 0 plus 1 and 1 minus 1 0 is skew symmetric. Skew symmetric, that means now you have to take transpose first and then taking minus common. If it is equal to the old one, then we will say it is skew symmetric. So 0, this row first will become column 0 1 minus 1, second column minus 1 0 plus 1, third row third column 1 minus 1 and 0. Now let us take minus common out of this matrix. So 0 minus common plus 1, then minus 1 minus 1 0 plus 1, this one, and this will become plus 1, then minus 1 and 0. Let us compare this matrix with the old one. 0 1 minus 1 minus 1 0 plus 1 1 minus 1 0. That means this is nothing but the old matrix. So A dash is equal to minus A, means matrix A is skew symmetric. Hence proved. Now we take question number 12. We have matrix A is equal to cos alpha sin alpha minus sin alpha cos alpha. Then we are asked to that A plus A dash is equal to identity matrix. It is given. Then find the value of angle alpha. So we will start with this matrix A plus A dash. A plus A dash is equal to identity matrix. This we have to take and then move. A is what? Cos alpha, sin alpha, minus sin alpha, cos alpha, and then plus A dash means transpose of this matrix. So this row will become column cos alpha minus sin alpha, and then cos alpha is equal to identity matrix means 1 0 0 1 of order 2 by 2. Then adding these two, cos alpha plus cos alpha 2 cos alpha minus sin alpha plus sin alpha this sin alpha minus sin alpha, this cos alpha plus cos alpha 2 cos alpha. So this cancel, we get 2 cos alpha and then 0 and then 0 and then 2 cos alpha is equal to 1 0 0 1. So here we can compare any of this 2 cos alpha with this right hand side, that is 2 cos alpha is equal to 1. This implies cos alpha is equal to 1 by 2. At what angle cos gives us 1 by 2? So cos pi by 3. Then cos removed, alpha is equal to pi by 3, 60 degree.